let's say we had maybe a 5x5 grid, and we wanted to find the number of ways where we can move from the bottom left corner all the way up to the top right corner. Again, if we can only move right and up. So like for this question, like again, we could use recursion. We could say, you know, there's one way, one way, one way, one way, two ways, and so on like that. But like, let's try to find like a better way to do it, since that can get tedious sometimes. So like the idea is, let's take a look at like a string of characters, R, 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 or let's say like we had a string of characters like R, 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 and U, 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 U. So just a term like string, just a string of characters is just like a word, basically. You can think of it. So basically, we have a string of length 10 consisting of 5 R's and 5 U's. So we can let R, like the letter R, represent one move to the right. And we can let the letter U represent one move up. So basically, the idea is like whatever string of length 10 that consists of 5 R's and 5 U's, that'll always correspond to like one unique path on the grid. So for example, this current string R, 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 U, 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 what this would mean is we first take 5 units to the right, and then we move 5 units up. So this string here would represent this sequence of moves. And notice that like no matter what, however we arrange these characters, we're always going to get exactly one possible path on the grid. So like, for example, if we like, you know, if we rearrange this string and we wrote it as like, for example, R, 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 U, U, R, R, U, 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 or something, right? Notice this still has length 10, and it still has 5 R's and 5 U's. This also corresponds to exactly one path on the grid. What this string means is that we're going to go right 3 times, then we're going to go up 2 times, then we're going to go right 2 times, and then the last 3 U's, that represents going up 3 times. So we can see that in this case, R, 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 U, U, R, R, U, 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 this word, this string, corresponds to this blue path on the grid. So the key idea to notice is that like, no matter what, like string of 10 characters, 5 R's, 5 U's, however we arrange those letters, that'll always correspond to exactly one path on the grid. And this is like a very important like kind of accounting technique. So it's often referred to as like one-to-one correspondence. Where we have like 2 separate things where all the things in one set map to exactly one thing in another set. So in this case, what that means is every string of 5 R's and 5 U's will map to exactly one path on this grid. So one-to-one correspondence, you might also sometimes hear this referred to as like a bijection, which is like a fancier word. It's a very important like technique in counting problems, one-to-one correspondences, because sometimes counting one thing is equivalent to counting another thing, but counting one of those things might be significantly easier. So in this case, to finish this problem, the number of paths from the bottom left corner to the top right corner is like equivalent to finding the number of different strings you can form from 5 R's and 5 U's. So with this string of length 10, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we have like 10 blanks, let's say we wanted to choose 5 of the blanks to put an R in, right? So maybe we choose this blank, this blank, this blank, this blank, and this blank, and we put an R in there. Then the remaining slots, you must put a U. So to choose which 5 slots you put an R in out of the 10 total slots, that's going to be 10 choose 5 ways to do that. And then afterwards, the U's will just fit into place. So that tells us there are just 10 choose 5 different like possible strings you can form from 5 R's and 5 U's. And if you were to calculate this combination using the combination formula, this is 10 factorial divided by 5 factorial times 10 minus 5 factorial. So this is 10 factorial times over 5 factorial times 5 factorial. And this is equal to 10 times 9 times 8 times 7 times 6 divided by 5 times 4 times 3 times 2 times 1. The 3 and the 2 cancel with the 6. One factor of 4 cancels with the 8, and one factor of 5 cancels with the 10. So if we were to simplify this, we would get 2 times 9 times 2 times 7. And if you were to calculate this out, you would get 252 as the answer. Yeah, so basically what we did is we noticed that like the key idea was that every path on this grid kind of corresponds to like exactly one valid string in this case. So in other words, if we counted the number of strings with 5 R's and 5 U's, then we automatically had a path on the grid. So that was a much easier way to like solve the problem.